searching, it is one of the operations of data structures, because we have so many operations which are performed by using the data structure. What is data structure? It is a list of elements, means a grouping of homogeneous elements in a single unit, that is called as data structures. So by using the data structures, we will perform so many operations like inserting an element, deleting an element, updating an element, searching an element. So this searching is one of the operations of data structures. So searching means finding, means we need to find a particular element in the list of elements, means in the list of element we need to find the position of the element or the desired element also, that means the key element also. So what is this searching? Searching is a process of finding a desired element in the set of elements. So set of elements is nothing but a data structure. So we may consider so many data structures like lists, array, linked list, tree or graph. So any of the data structure, if we consider any of the data structure, we need to find the element, the particular element called the desired element in that list of elements, in that set of elements. So that desired element is called as target. That desired element is called as target. So searching means we are finding. So we are finding for a particular element. So why we find a particular element means to processing on that data, means we need to perform some operation on that data. Definitely we will find whether the element is existed or not, means in that particular set sometimes we are finding for a particular element, so the element is not existed. So how we will find that? So we are searching the element. So for searching we will follow different techniques. So what are the techniques we will follow and how we will find a particular element, we will see. So various algorithms have been defined to find whether an element is present in the collection of elements or not. That means different type of algorithms are used whether the element is existed in that particular list or not. For example, we'll see a particular array. So for example, int a. So a is of array. So array means it definitely stores some integer type of data. For example, int array of 3. So this array consists of 3 elements, 1, 2, 3. That means the array A consists of 3 elements. So what are the 3 elements it is stored? 1, 2 and 3. Now it is the task to us. What is the task? We need to find whether 4 is an element which is present in this particular array or not. So to find that we will use different algorithms. So tell me whether 4 is the element of this array A or not. No, this is not the element of array A, because the array A consists of only 3 elements, that is 1, 2 and 3. But 4 is not the element. So for example, element 2. So element 2 is the one of the element of this array, and we will find the position of the 2 also. So what is the position of 2? So this is the 0th position, and this is the first position, and this is the second position. Because if the array size is n, definitely the positions are the range of the positions are from 0 to n minus 1. So that's why the position of element 2 is 1. So like that, by using the searching algorithms, we will find whether the element is existed in the list or not, and if the element is existed, then what is the exact position of that particular element. So we will find the address of that element also. So by using this searching concept, that means to perform some other operations, the searching algorithm is very easy, and this algorithm can be executed on both internal as well as external data structures. So internal or external data structures, this algorithm is used. And to improve the efficiency of any algorithm, we need to improve the efficiency of searching. So for example, if you want to perform an addition operation of two elements, so two different addition operation on two different elements, and one element is taken from one set and another element is taken from another set. So some set operations are there. So if you want to perform an addition or union operation on two set operations, so to perform that, definitely you need to take an element from set 1 and you need to take the element from set 2. So sometimes you need to find the elements also. So for improving the efficiency of the algorithms, we need to improve the efficiency of this searching algorithm. So whenever we will find the element in better cases, means with a less time, within the less time if you find an element, then you can easily improve the efficiency of the algorithms. So for finding the elements we are using searching techniques. So for better efficiency, to improve the efficiency, we will follow two different techniques. One is sequential search, another one is binary search. So these are the two techniques used in searching. So what are these two? So for example, if you consider the sequential search. So what is sequential search? Sequential search is also called as linear search. So this is one of the searching technique. So the name itself indicates that it is searching the elements in a sequential order. That means if you want to find an element, then obviously it will traverse from first element to last element, and each element is compared with the key element or target, whether the element is matched or not. So if the element is matched, then definitely it will give it as a result. If it is traversed from first to last and the element is not present, then simply it will give the element is not existed. So like that it will give the report by traversing from first element to the last element. So that is called as linear search or sequential search. So this is the one of the techniques of searching. So this is the good technique and is used to find the elements. But why we move to the next one, that is called as binary search? So what is the purpose of this binary search? Why we move to this one? Because linear search is good, but this is also having some disadvantages. So what are the disadvantages with linear search? Mean whenever we are searching for an element, so many cases are there. For example, if you consider the three cases, the element will be found at the starting position, means the finding element is located at the starting position, that means first position. So directly, immediately when we compared with the first element, then immediately we will found the element is located. So then the time complexity is very less, and this is the best one. And in some cases, in the middle of the list, means at any position, it may be second, it may be third, it may be fourth position, it may be fifth, or it may be sixth, like that, at anywhere the element will found. That is another case. And the last one is the element will be located at the last position. So if the element is located at the last position, then if the list of elements is very less, then no problem. We will traverse from first element to the last element and we will found the element. But if the list of element is more, mean the number of elements in the list is more, then for getting the element, for finding the element which is located at the last position, we need to traverse from first to last before element. So that will take so much of time. That means the time complexity is more to find the element whenever it is located at the last position. So that is the main drawback with linear search. So to overcome that, we move to the next one, that is called as binary search. So here how we can overcome it, how we can overcome the problem of linear search. So here the binary search will follow the divide and conquer method. It will follow divide and conquer. That means we need to divide the data and we need to apply the algorithms. After finding the results, again we will conquer. Conquer means combine the data. So we need to follow this divide and conquer technique in binary search algorithm. So what is this? What does this mean? Instead of traversing from first element to last element, here the key element is directly compared with the middle element. So instead of comparing from first element onwards, it is directly comparing the middle element. Then how we will find the middle element? How we will find the middle element and how we will perform it mean, here is one case is there. This binary search is only applied on the sorted data. Sorted data. What is sorted data? Means the data is particularly arranged in either ascending order then or descending order. Then only we will apply the binary search. So if the elements are arranged in ascending order, then directly the key element is compared with the middle element, and after comparing with the middle element, it will conclude to which sub array is considered to find the element. So that means half of the elements are eliminated. So the same process is repeated until we find the element or we does not find the element. So here the time complexity is very less comparative to the linear search algorithm. So in the next videos we will see what is linear search algorithm with a proper example and explanation. Thank you.